All right, so let's do 57 and 10.3. 37. 37. So what we have is an average of 50,000 people visit Riverside Park each day in the summer. So 50,000 people per day, right? The park charges $15 for admission. What a ripoff. So that's $15 per person, right? Consultants predict that for each dollar increase in entrance price, the park would lose an average of 2,500 customers per day. Okay? So, $1 increase implies 2,500 people decrease. You guys see that? Okay. Express the daily revenue from ticket sales as a function of the number of $1 increases. Cool? So I'm supposed to write a revenue function as a function of increases, right? Cool? And then what price maximizes revenue? Okay, cool. What are you thinking? Crap?
Plus I. It's going to be a part of it some way.
Okay. The I is going to go together with a 15, right? You guys with that? So, how would if I did this? What if I think about revenue as a function of increases, right? What if I just think about revenue in the dumbest possible way? So what's your first blow thought for revenue? How much do they make in a day?
50K times 15.
Okay. So I think maybe they make, I'm going to split that into two pieces. You guys said 50K times 15, right?
Yeah.
Okay, what was the 15? Yeah, that's the price per person, right? So I'm going to split that into a price per person. And what were you multiplying by? 50,000, which is what?
Average people per day.
Yeah, that's the number of people, right? You guys see that? Like, my revenue is going to be the cost per person times the number of people. You guys all see that? Okay, so let me straighten out cost per person. There's definitely a 15 to start with, right?
Yeah.
And then,
Times P or times amount of people.
yeah, okay, so what's the I stand for? What was that thing?
$1 increase.
Yeah, that's going to be the number of, so this guy, this I, is the number of $1 increases.
So it's going to be 15 plus 1. 50 plus I.
Yeah, so it's going to be 15 plus I is going to be the new cost, right? You guys all see that?
0 stays at 15. I is 1 is 60. I is 2 17.
You guys see that? So this piece is going to be the base price, $15, plus the number of increases that we've made. Then what's my number of people going to be? You guys said it starts out at 50K, right? Okay, so it's 50,000 minus, why am I subtracting?
Because you lose people per increase.
Yeah, because every time we jack the price, less people show up, right?
So that's 2,500 and or I or something.
Okay, so I need to subtract 2,500 times I. You guys see why?
Yeah, because it's a decrease. Well, because that's it. That
Because every
that is
number-
determined.
Yeah, so every $1 increase, right? Every time I tick I up by 1, I'm going to lose 2,500 people. So if I leave I at 0, right, just to check that this is working, I should check. All right, if I plug in I as 0, $15, that's with no increase, right? And 50,000 people. Cool, that seems to be working. Let me check one more. What if I do $1 increase? What's my new price?
16.
16. And how many people? Yeah, whatever 2,500 less than 50,000 is. You guys see that? All right, now they want to know when this thing is maximized, yeah?
Yeah.
Okay. How do you do that? Guess and check.
You'd be there for
No.
a long time.
Easier than guess and check.
You're gonna solve it for something.
Good, you could shove this in a graphing calculator and ask the graphing calculator for the maximum, or you could use your brain. Yeah. Let's try using our brain. That'd be crazy, right?
You can grab it with your brain.
Could you divide the 50K by 200 and 2,500?
What's that going to correspond to? That's good.
The maximum price that you can up it? Or
Yeah, that's going to be a little funny, right? You guys see that? That's like once I've raised the price so much that no one comes to the park. That's really me applying the zero product rule to this thing. So if I set this thing equal to 0 and apply the zero product rule, right? I'm really looking to solve when is 15 plus I, really I'm thinking zero product rule, right? When is 15 times I plus times 15,000 minus 2,500 I equal to 0? Well, one of those times is when I've jacked the price so much that no one wants to come play anymore, right? So that's this guy. What does that give you? You guys can, what's your I for that? Okay.
Plus I.
Don't be scared.
20.
Slash some zeros and then think. I think it's 20. So if I increase the price $20, nobody's going to come. And this one's going to be even weirder. What's the other way I could make no money?
By subtracting the price to 0.
Good. I could do negative $1 increases, right? And get to I is minus 15.
Wait, so to make it free, no one shows up.
Wait, wouldn't you?
No, if I make it free, my revenue is 0.
Why would you use
Got
negative
it.
15? Why wouldn't you just use? Oh, okay, never mind. Minus 15 makes sense.
Oh, and then
Never
you have
mind.
to
I'm sorry.
figure out when between 15 and 20.
Good.
15 and
This thing is a parabola, right? You guys all see that? If you FOIL this crap out, you get a parabola pointed downwards.
Yeah.
Parabolas are symmetrical. So I'm exploiting that. I found out where it hits the x-axis, right? So here's what I know. I know I've got a parabola pointed down. It hits the x-axis here at minus 15, or the y-axis really, right? At 15 and 20.
So wouldn't it be the median then at 5?
the middle in between.
Alright.
Good, it's the middle. What's the middle between 15 and, or minus 15 and 20?
Uh,
15,
What?
35. It's
17.5.
gonna be like 25 and a half or something?
Okay, so this distance is 35, right? So that means the radius, right, is 17.5, 17 and a half, right? Or
So it's gonna
or screw it, 35 over 2, right? And so where's my middle here?
17.
And whatever you put 35.
Whatever 35 over 2 is, yeah.
It's at negative 15 plus 35 over 2. I just circled this like really confidently. What do I need to do?
20 backwards as well.
Yeah, we could have gone from 20 backwards. This number, 15 plus 35 over 2, is the same thing as 20 minus 35 over 2. Assuming that I did this 35 over 2 thing, right? You guys all see that? Vertex has got to be in the middle here. So, what do I write? 'Cause I circled that with confidence, but what should I actually be doing?
You achieve maximum profit at an increase of that time.
So maximum revenue is not quite maximum profit, but it's close, right? So maximum revenue is at
$17.50 per ticket.
a price of $17.50 per ticket. Right? And what did they actually ask? So I should go back and reread. So what ticket price maximizes?
Be whatever 17 plus
17.
minus or one of those two other things.
Hang on, what?
If it happens at 17 and a half, you have to plug it in and doesn't it not? It wouldn't
Oh,
be
yeah.
a 17
So-
and a half increase, it would be whatever you get at 17 and a
Yeah,
half.
so this doesn't happen at 17 and a half.
Happens at 2.
This number is 2.5.
Yeah, okay.
You guys all see that? So this number here is I is 2.5. Right, and some of you guys just jump to a ticket price of 17 and a half. You guys see that?
That's the number of $1 increase.
Yeah, this is a number of $1 increases. And really the 17 and a half is right here, yeah?
Yeah.
Because it's 17 and a half $1 increases from making it free. So it's a ticket price of 17 and a half dollars. Does that make sense?
Yeah.
Okay, other thought, how else could you have done this?
Oh, what?
Just find
Find
some
the
vertex
vertex
on
minus
something.
B.
Yeah, I need to find a vertex, which is minus b over 2a, you might remember.
Too.
And that happens because the quadratic formula has that plus or minus in it. That plus or minus is going to be this distance. The minus b over 2a is going to be wherever this happens. So you could also do that. Right? To get that, you would have to multiply this crap out and identify b and a.
Yeah.
And then remember this minus b over 2a thing. Other questions? Anybody else? Good on this?
Yeah.
Okay.
43?
Yeah. Remember, your last step on word problems should be to write a sentence and answer like a person.